Today we're going to do some additional notes from Chapter 5, Sections 5.1 and 5.2. So we're going to start out filling in the unit circle. Now we've already talked about this in section before, but we're going to go ahead and look at it one more time. So when we look at the unit circle, we know that unit means that the radius is 1. And we know that the radius is the distance from the center of the circle to a point on the circle. So all of these lines that are going like this are all going to be length 1 when we talk about a unit circle. So the first thing we're going to look at is the unit circle cuts this circle into 4 pieces with these lines, the vertical and the horizontal line. And so we're going to call those quadrants. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, you know that already from your algebra days. We also know that if I go to the right, it's positive, and if I go up, it's positive. So my positive negative would be positive, positive. I go to the left, it's negative, and I go up, it's positive. So I know this one's going to be negative, positive. Left and down gives me negative, negative. And then right and down gives me positive, negative. So next thing we're going to do is find the degrees. The degrees has to do with the angle measurements as we go around the circle. So we're going to start out this being 0 degrees on the positive x-axis. So we start here. And we're going to look at all the way around the circle. We know all the way around the circle is 360 degrees. So we're going to write 360 degrees. Now, if I have these 4 pieces that 360 degrees is cut into, then 4 pieces makes each of them with 90. So we know from 0 to this one up here is going to be 90 degrees. Plus another 90 to get me over here is 180. Plus 90 again is 270. And plus 90 brings me back to 360. So that's the first ones we're going to fill in is the quarters. So 90, 90, 90 all the way around. The next thing we're going to do is we're going to put a little squiggly line on this middle one. So we know that if from here to here is 0 to 90, that this is going to cut it into 2 pieces. So each of those pieces is going to be 45 degrees. So here's 45 degrees for this one. Plus 45 degrees gives me the 90 that's already there. Plus 45 gives me 135. Plus 45 gives me 180. And I continue around the circle. So 45 gives me 225. 45 is 270. 45 again gives me 315. And 45 again gives me 360. Okay, next one we're going to look at then is these additional lines that we still have left over. So if I know this is 0 and this is 90, and it cuts it into 1, 2, 3 pieces, because we're going to pretend that squiggly line one's invisible. This is going to be 30 degrees. 30 plus 30 gives me 60 degrees. Plus 30 gives me 90. Plus 30 gives me 120. Plus 30 gives me 150. And I keep going all the way around. Plus 30 is 180. 210. 240. 270. 300. 330. And 360. So now we have all the degrees all the way around. So that has to do with the angle measures. So the next thing I'm going to ask you is from here all the way around, if I were to measure that distance all the way around the circle. From your geometry, what did you call that? You called that circumference. So the circumference formula is 2 times pi times r. R stands for radius. Well, if our radius is 1, and I mark through and make that a 1, then my distance around my circle is going to be 2 pi. So I start at 0 and I go all the way around, and that's going to be 2 pi. Now, if I take 2 pi and go all the way around, that's 2 pi, but if I stop half of the way around, if it's 2 pi total, then half of the way around is going to be 1 pi. So if this is 1 pi and I cut my pi into 2 pieces, then this is going to give me 1 piece, 2 piece. So 2 pieces is going to make each of them worth half of the pi. So pi over 2. Pi divided by 2 would give me what each of those are. So this is 1 half, 2 halves, 3 halves. So this is 3 pi over 2. And then back to 2 pi again. So now we want to do what we did before. We want to count the number of pieces. So right here, this is going to be 1 piece, 2 piece, 3 piece, 4 piece. So I've got 1, 2, 3, 4 pieces. With those 4 pieces, I've got a pi. So if I cut a pi into 4 pieces, then each piece is worth 1/4 of the pi. So I've got pi divided by 4. So 1 pi divided by 4 gives me pi over 4. The next one would be 2 pi over 4. So if I have 2 pi over 4, the 2's cancel, and that gives me pi over 2. So 1 pi over 4, 2 pi over 4, this one's going to give me 3 pi over 4. 4 pi over 4, the 4's are going to cancel and give me pi. 5 pi over 4. 6 pi over 4, if we have 6 pi over 4, that reduces down to be 3 pi over 2, which is what we already have. 7 pi over 4, and 8 pi over 4. 8 pi over 4 would reduce down to 2 pi. So now we did the fourths. Now we're going to come back and do the 30s and the 60s. So we count the number of places there. So there's 1 piece. This is invisible now. So 2 piece, 3 piece, 4 piece, 5 piece, 6 piece. So there's 6 pieces. So if I have a pi and I cut it into 6 pieces, then each piece is pi over 6. Pi divided by 6 would be 1/6 of a pi for each piece. So 1/6, 2/6. So if I have 2 pi over 6, the 2 is going to cancel with the 6 and give me pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2, but it's already there. 4 pi over 6 is going to give me 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6, and we're just counting around. 1, 2, 3, 4, 5, 6 pi over 6 is going to cancel the 6's out and leave me with pi. So this one would be 7 pi over 6. 8 pi over 6, 8 pi over 6 reduces down to be 4 pi over 3. And then, so 9 pi over 6 is here already. So 10 pi over 6 gives me 5 pi over 3. 10 pi over 6, so this is going to give me 11 pi over 6. And then back to 12 pi over 6. So now we have all the degrees, we have all the radians, we have the quadrants, and we have the plus and minuses. So the next thing we got to look at is these coordinates around the outside of the unit circle. So we're going to come down here to these special case triangles. So we have one here that's the 30, 60, 90 triangle. And then we have one that's 45, 45, 90. So on this one, this is the shorter side, this is the longer side. So I want you to remember, the 30 is the shorter side, and it's going to be 1/2. The 60 is the longer side, and it's square root of 3 over 2. And the hypotenuse is 1, because we use it in the unit circle. Now, we went over how to do square root of 3 over 2 and how to do 1/2 with a previous video. So the same thing with here, 45, 45, 90. Now, the thing about 45, 45, 90 is since these two are the same, we know this is an isosceles triangle, so the sides have to be the same. So this is square root of 2 over 2, square root of 2 over 2, and 1. Okay, now before we use the special case triangles though, we're going to fill in the ones that are on the quadrants. So this one right here, I would go out 1, but I wouldn't go up or down, so I'm going to have 1, comma, 0. 90 degrees and pi over 2, we're not going left and right, so we get 0, comma, 1 because we go up 1. This one over here, negative 1, comma, 0 because we're going left 1, but we don't go up or down. And this one down here is going to be 0, comma, negative 1 because we're going down, but not left or right. So the next one up from that, we're going to drop our perpendicular. And then we know this is 30, and we know this is 60 because this is perpendicular, it's 90. So this is the point I'm trying to get to. How far out do I have to go and how far up do I go? Well, if the hypotenuse is 1, we're talking about taking this special case triangle and placing it right there in the unit circle. So this is the longer side, this is the shorter side. So what did we say the longer side was? The square root of 3 over 2. The shorter side was the 1/2. So this order pair is going to be square root of 3 over 2, comma, 1/2. The next one, when we drop it, we know that it's the 45 because it's that middle one. So 45, 45, 90 is going to give me the same thing on both sides, square root of 2 over 2, square root of 2 over 2. The next one, we drop the perpendicular. So now this one is short side, long side. So short side first, long side second is going to give me 1/2, comma, square root of 3 over 2. So that gives me quadrant 1. Now notice each of them positive, 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 positive as you go across. So now we're going to drop this perpendicular over here for the next one. So short, long. This is the short side, this is the long side. So this is going to be 1/2, but we're going to the left. So 1/2 to the left is going to give me negative 1/2. Longer side is going up, so positive square root of 3 over 2. 45, remember the 45 is going to be the same on both sides. So I've got negative square roots of 2 over 2, square roots of 2 over 2. Dropping this one, we have long side first and short side second. So out left would be a negative square root of 3 over 2, positive 1/2. So each one in here is negative, positive, negative, positive, negative, positive, because you're in quadrant 2. So you're going to continue that around, dropping the perpendiculars and telling me what it's going to be. So this one, long, short, so negative square root of 3 over 2, negative 1/2. Same on the 45, so square root of 2 over 2, negative, and negative square root of 2 over 2. This one, short side, long side, so negative 1/2, negative square root of 3 over 2. In the last quadrant, we've got plus minus. So the same thing, we've got long side, short side. So square root of 3 over 2, comma, negative 1/2, because we're going down. Middle one, same. So we've got positive square root of 2 over 2, negative square root of 2 over 2. And then the last one is short side, long side. So positive 1/2, negative square root of 3 over 2. Okay, I'm going to give everybody a minute or two to see about getting that all written down on their paper. Okay. You also have a key, I think, that's attached as one of your notes too as well. So the next thing we're going to look at is where an angle is located and what its reference angle is. So we know in a unit circle, or in circles, if I start from the positive x-axis and go counterclockwise, that's going to be a positive angle. If I go clockwise, that's going to be a negative angle. So I'm going to ask, where is the angle located, and what is its reference angle, and what is its point? So I have negative 7 pi over 6. So if we consider the unit circle, we have these marks that are the sixths, right? So if you have your unit circle in front of you, negative pi over 6, though, starts from here and goes negative. So 7 pi over 6 would be 1, 2, 3, 4, 5, 6, 7. So we're looking at this line right here. Negative 7 pi over 6 then would be in quadrant 2, because this is quadrant 1, 2, 3, and 4. So it's in quadrant 2, and we said we also want to know the reference angle. So that reference angle always goes back to the x-axis. So we know that reference angle is going to be pi over 6. Now the coordinates, if I drop my perpendicular and I look at it, this is long side, this is short side. So I'm going to have negative square root of 3 over 2, comma, 1/2. So 3 different things: quadrant, reference angle, point. And that's for negative 7 pi over 6. Okay, let's try another one. 7 pi over 4. Now, 7 pi over 4, we're going to take and cut it into fourths. So we got fourths this time. So 1, 2, 3, 4, 5, 6, 7 would give this 7 pi over 4 over here. So we know we're in quadrant 4. Dropping back to the x-axis is going to give us a reference angle of pi over 4, because we've got one more pi over 4 to get to that line. And then we know that we're fourth quadrant, we've got positive, negative, same, because it's 45. So positive square root of 2 over 2, negative square root of 2 over 2. So this is why it's important that you know the unit circle, because each of these things we're pulling off of the unit circle. So we're okay with that? All right, now we're going to go ahead and talk about SOHCAHTOA, which is something that you learned about in geometry. So we have that funny word, we're going to find the 6 trig functions. In the unit circle. So we're going to start by drawing ourselves a picture. Okay, give everybody a chance to draw the picture first. So this is across the x-axis, so that distance is x. This is vertical, so this is going to be y. And since we're in the unit circle, that's going to be 1. Now, you guys learned in geometry this saying SOHCAHTOA. So we said back then, SO stood for sine, CA stood for cosine, and TOA stood for tangent. So we're going to deal with those 3 first, and then we'll come back and do the other 3. So we're going to have sin theta. Sine stands for sin. So we know sine is opposite over hypotenuse. So opposite of the theta is going to be the y. Hypotenuse is going to be the 1. Now, sine y over 1 is just going to be y then. Cosine theta, we know is the A stands for adjacent, which means next to hypotenuse. So adjacent over hypotenuse is next to is x, hypotenuse is 1, so I get x over 1 equals x for cosine. Now I have tangent theta. Tangent theta is TOA, so opposite over adjacent, so opposite is y over x, so I've got y over x. Now we also know something about tangent though, because sine and cosine. Sine is the y and cosine is the x. So that means over here that we can rewrite this as sine theta over cosine theta for tangent. So we've got sine, cosine, and tangent. Now the other three are what we call reciprocal functions. So the first one we're going to look at is cosecant. CSC of theta is the reciprocal of the sine. So the sine is y over 1, so cosecant's going to be 1 over y. Next one is secant. SEC theta is 1 over cosine theta, which we know cosine is x over 1, so its reciprocal will be 1 over x. And the last one is cotangent. So we know cotangent theta is the reciprocal of tangent. So if reciprocal of tangent, you have y over x, so we're going to have x over y. And we're also going to have cosine theta over sine theta. Okay, I'm going to give everybody a minute to get that written down first. Okay? So now we're going to use those to read values off of the unit circle. So we're going to find the sine of 3 pi over 4. Now, what we just wrote down was cosine is the x and sine is the y. So we're going to write it up here. Cosine theta, comma, sine theta. This is the x, this is the y. So we're going to go to 3 pi over 4. So 3 pi over 4, 1, 2, 3 pi over 4 would be here. We know that since it's a pi over 4, it's going to be same, so the ordered pair is going to give us negative square root of 2 over 2, comma, square root of 2 over 2. So now since we're looking for the sine is the y value. So my y value for sine 3 pi over 4 is going to equal square root of 2 over 2. So that would be my trig ratio. Okay, let's try another one. Cosine 7 pi over 6. So again, we go to our unit circle and we find 7 pi over 6. 7 pi over 6 is in quadrant 3. So we know from unit circle, negative, negative. So I have negative square root of 3 over 2, negative 1/2 as my ordered pair. Since I'm looking for cosine, I know cosine is the x value. So I pull off the x value and I get negative square root of 3 over 2. That's my trig ratio for cosine 7 pi over 6. Okay, let's try a tangent now. So tangent of, let's see, 5 pi over 3. So we're going to look on our unit circle. This would be 1, 2, 3, 4, 5. So 5 would be down here. So we're going to have 5 pi over 3. The ordered pair is going to be 1/2, comma, negative square root of 3 over 2. Now with tangent though, we don't have an x or a y like this. This is cosine and sine. But we do know that tangent is sine 5 pi over 6 divided by cosine 5 pi over 6. Oh, I'm sorry, 3. Yes. So sine over cosine. We know sine is the y value, so I get negative square root of 3 over 2 divided by 1/2. So this is division on a fraction, so I'm going to take negative square root of 3 over 2 times the reciprocal of this would be 2 over 1. So the 2's cancel, and I get an answer of negative square root of 3. All right, let's try to find one where you have to find where the value is. So if I give you, I want to find the cosine of 41 pi over 6. Now, 41 pi over 6 is not on our unit circle. So what we have to do is we have to simplify this such that we find out where its angle would be. So I have 41 and I divide by 6. And that goes in there 6 times, so 36, subtract gives me 5. So I get 6 and 5, 6 pi for 41 pi over 6. Now, each time that I go around the unit circle, it's 2 pi, 2 pi, 2 pi, 2 pi. So I'm going to take away all the 2 pi's that I can because I don't care how many times around. I want to know where I stop. So I'm going to minus 6 pi because that's 3 times around the circle. 2, 4, 6, right? So I'm left with 5 pi over 6. So now what I'm really looking for is cosine of 5 pi over 6. So that can be found in the unit circle. So cosine 5 pi over 6 would be over here, quadrant 2. We know the coordinates of that is going to be negative square root of 3 over 2, comma 1/2. So we're looking for cosine. Cosine is the x. So this is x and y. So my answer for cosine 5 pi over 6 is equal to negative square root of 3 over 2. Okay, let's try a cotangent or a cosecant, one of those kinds. So let's try a cotangent of 16 pi over 3. Now, again, 16 pi over 3 is not on our unit circle, so we have to simplify it to get it to where we find out where we stop. So I'm going to take 16 and divide by 3. That gives me 5 and 1/3 pi. Now, we said we were going to take care of all the 2 pi's. So 2 pi, 2 pi, 2 pi. So we're not just going to take the 1/3 pi because 5 is not a multiple of 2. So we're going to subtract 4 pi. So 2 times around the circle. So that leaves me with 1 and 1/3 pi. So I go to my unit circle. And 1 and 1/3 pi, this would be 1 pi plus 1/3 pi more is going to be down here. So that's 1, 2, 3, 4 pi's, right? This would be 4 pi over 3. So we know this ordered pair is negative 1/2 negative square root of 3 over 2. So we're looking for cotangent of that point. So cotangent is going to be the cosine of 4 pi over 3 over the sine of 4 pi over 3. Because now we're reduced down here to this 4 pi over 3, right? But we could write it as 16 pi over 3 as well, too, if you wanted to. So cosine 4 pi over 3, we know is the x value. So I have negative 1/2 over sine is negative square root of 3 over 2. So I have negative 1/2 times the reciprocal 2 over negative square root of 3. So the 2's cancel. Negative divided by negative gives me a positive 1 over square root of 3. But we can't leave it like that because it's got a radical in the denominator. So I multiply the top and the bottom, the numerator and the denominator, by square root of 3. So I get cotangent 16 pi over 3 equals square root of 3 over 3. You have a chance to get that written down first. Okay. Okay, now we're going to find some values on our calculators. So we're going to pull out your calculators. If it doesn't say degrees on it, then we know that it's radians. So we've got to change our calculator to radians mode. So a lot of your calculators, if you push mode, then you should be able to see degrees and radians on there. And you want to change it into radians mode first. So if it's in radians mode, all you have to do is push sine 2.2. Now we're going to put a little squiggly equal sign to indicate that you're simplifying. So I think you get something like 0.80. Let's put it on the calculator, I'm sorry. Okay, 0.8084964. 1, 2, 3, 4, 5, 6. So we really don't need that last one. Just be aware of what they say to round to on the exam when you take it. You have cosine 1.1. So you're doing the same thing. You push cosine 1.1 as long as you're in radians mode. And you get squiggly equal sign 0.453596. Now, if I do one like cotangent 28, the thing about cotangent is we don't have a cotangent button on our calculators. So what we're going to do is we're going to change this to 1 over tangent of 28. And then again, squiggly equal sign, you're going to take 1 divide tangent. So we've got 1 divide tangent 28. And you should come out with that one as negative 3.55328. 1, 2, 3, 4, 5, 6. Okay, so we're okay with that? So reading values off the calculator. Okay, the next thing we're going to look at is Pythagorean identities. Pythagorean identities, we're going to start out with a picture again. Now, we said in a unit circle, so again, this is a unit circle each time we're talking about circle here. We know in a unit circle, this is cosine theta, comma, sine theta. So if I go out and up, this is going to be my cosine theta, and this is going to be my sine theta. And we know since we're in a unit circle that our radius is going to be 1. So we're going to talk about Pythagorean identities. Now, Pythagorean identities, if we have cosine and sine, these are the legs of a right triangle, and this is the hypotenuse. So Pythagorean theorem says that if I have a right triangle and I know the legs and I know the hypotenuse, then this is a squared plus b squared equals c squared is what you're used to saying. We're going to have cosine squared theta plus sine squared theta equals 1 squared, but 1 squared is just 1. So this would be my first Pythagorean identity. And where do we get it from? The Pythagorean theorem. Cosine squared theta, sine squared theta equals 1 squared. The second one we're going to do, we want a tangent in one of them, so we're going to divide by cosine squared all the way across. So we're going to start with cosine squared theta plus sine squared theta equals 1, and we're going to divide by cosine squared all the way across. So this becomes 1. So 1 plus sine over cosine is tangent squared theta. And then 1 over cosine squared would be secant squared theta. So this gives me my second Pythagorean identity. So we've got sine, cosine, tangent, secant. So we probably want one that has cotangent in it. So we're going to start again with cosine squared theta plus sine squared theta equals 1. Since I want cotangent this time, I'm going to divide by sine, because we know cotangent is cosine divided by sine. As long as we do it all the way across, then it's still going to be an equivalent expression. So cosine over sine gives me cotangent squared theta. Sine divided by sine gives me 1. 1 over sine squared gives me cosecant squared theta. And there's my 3 Pythagorean identities. Okay, now we're going to use the Pythagorean identity to work a problem. So we're going to pull this off to the side for a second. It's going to say, use Pythagorean identities to solve for 6 trig functions. Use Pythagorean identities to solve for 6 trig functions. So our problem is going to say tangent of t equals 1/4, and t is in the 3rd quadrant. So we have tangent given to us, so that's the first one. So we already know one trig function. So now we're going to look at our identities. We've got 3 different identities, but if they give me tangent, I'm going to use this one because this one has tangent in it. So I'm going to write down 1 plus tangent squared theta equals secant squared theta. And I'm going to place 1/4 in for tangent. Okay, so we put in 1/4 in for tangent. So now we're going to simplify. So I get 1 plus 1 squared over 4 squared would be 1/16 equals secant squared theta. Now for me to put these two together, I have to have a common denominator. So this is going to be 16 over 16. Plus 1 gives me 17 over 16 equals secant squared theta. Now we're looking for secant, not secant squared. So we're going to take the square root. So this gives me secant theta equals plus and minus square root of 17. Square root of 16 is 4. Now, with the reason why we had to know what quadrant we were in, if we're in 3rd quadrant, secant is the reciprocal of the cosine, so cosine is negative in quadrant 3. So that means secant is going to be negative in quadrant 3. So I have secant theta equaling to negative square root of 17 over 4. Now, we just said that we have reciprocal functions for both of these. So tangent's reciprocal function is going to be cotangent. So I'm going to get 4 over 1, or 4. Secant is going to give me cosine, which is negative 4 over square root of 17. But we can't leave square root of 17 in the bottom, so I have to multiply square root of 17 in the top, the numerator and the denominator. So that gives me cosine theta equals negative 4 square roots of 17 over 17. So the last two that we need to find, so we've got cotangent and tangent, cosine, secant. So now we're looking for a sine. So we're going to use sine squared t plus cosine squared t equals 1. So I'm going to put in here, so I get sine squared t plus cosine is going to be negative 4 square roots of 17 over 17. Now, if we wanted to, on this one, to make it easier, we could go back before we simplified and use that negative 4 over square root of 17, in which it might actually be easier. So let's go ahead and rewrite this as sine squared t plus negative 4 over square root of 17 squared equals 1. It's just going to be the same answer. It's just this one's going to need a little bit more simplifying. So if we go back before we simplify that, we can still use that one. So I get sine squared t plus negative 4 times negative 4 gives me 16. Square root of 16 squared gives me 17. Now I'm solving for sine, so I need to get this 16 over 17 to the other side. So I subtract 16 over 17 from both sides. So that gives me sine squared t equals 17 over 17, because it's a whole. Subtract 16 gives me 1/17. And then we're going to take the square root on both sides. So I get sine t equals 1 over square root of 17, plus and minus. So we have to multiply by square root of 17 in the top and the bottom. So we have to decide plus or minus. So we said we were in third quadrant, so we know sine is negative. So we're going to have sine of theta equals a negative square root of 17 over 17. So now we want to find cosecant theta. So cosecant theta is going to be the reciprocal of sine, so we're going to go back here to this. So we're going to get square root of 17 over 1, which is just square root of 17, but we know we're in quadrant 3, so it's going to be negative square root of 17. And so then we've used it to find all 6 of the trig functions. Okay, the last thing we're going to do on this section, this notes, is we're going to play a little game called Name the Quadrant. All right, so we know our unit circle. That's the first thing. We had to make sure we knew the unit circle. So in the unit circle, we're going to write this is going to be quadrant 1, 2, 3, 4. We know quadrant 1 is plus plus, quadrant 2 is negative positive, quadrant 3 is negative negative, quadrant 4 is positive negative. So give everybody a chance to get the picture drawn first. All right, so it's going to say cosine theta is greater than 0 and tangent theta is less than 0. So they want you to find the quadrant where cosine is greater than 0 and tangent is less than 0. So greater than 0 means cosine is positive. Tangent less than 0 means tangent is negative. Now, we need to remember that tangent is sine theta over cosine theta. And we also need to remember that cosine theta, comma, sine theta. So cosine is the x and sine is the y. So first, where is cosine positive? Well, we know cosine's positive where the x is positive. So we have quadrant 1 and quadrant 4. So a choice between 1 and 4. Of those two, between 1 and 4, we want tangent to be negative. Well, if I take positive divided by positive, we know that's not negative. If I take negative divided by positive, we know that is negative. So my answer is going to be quadrant 4. Okay, let's try another one. Secant theta is greater than 0 and sine theta is less than 0. Now, we know again, this means positive. But if secant is reciprocal of cosine, we're looking for where cosine theta is positive. And we're looking for where sine theta is less than 0, which means we're looking for sine theta less than 0 is negative. So we want cosine positive, sine negative. So where is cosine positive? We already said that was 1 and 4, right? So of 1 and 4, where is sine negative? Sine is the y value. So between 1 and 4, sine being negative would be, between 1 and 4, sine being negative would be 4. Okay? So you get the idea for name the quadrant? Thank you very much.